All right, today we are going to take some quick notes on ratio tables because ratio tables is just one other way to look for equivalent ratios. It's a way to look for equivalent ratios, and oftentimes they use real world problems. So we're going into looking at actual data, actual things, ratios based on real things. So you will be exposed to ratio tables, and there are two different kinds. So I'm just going to basically use this as an opportunity to go through two examples with you, so you get the idea of how to do a ratio table and what it looks like. So the first thing we're going to do is we're going to create a ratio table, which is just a chart, and we're going to fill it out. So I'm going to write example 1. I don't think we need to go over any sort of vocabulary because you guys have already kind of learned all the vocabulary needed. So, this problem is about students in the school musical, and they're going to sell tickets. Okay, so I'm going to say each student must sell 3 child tickets or youth. The book says youth, but we're going to go with child tickets. And 5 adult tickets. I bet some of you have had to sell tickets or raffle tickets or things if you play sports or anything. You've tried to sell tickets to things before, and you have a goal because you're trying to raise money. That's what this is. Okay, so these children are in a play and they have to sell tickets in order to raise money. We are going to try and figure out how many tickets are sold if there are 50 children. Or students. I should say students to go with what we are doing. Okay, each student, there's 50 students. Each student must sell 3 child tickets and 5 adult tickets. And you probably can do that in your head. But we're going to go ahead and look at a ratio table. So we're going to make the number of students in one column. Then we're going to put the number of child tickets. And then we're going to put the number of adult tickets. And in our ratio table, we're going to have 1 student. We're going to have 2 students. We're going to have 3 student. We're going to have 4 student. And then we're going to go ... 50. So we know that one student must sell 3 tickets for children and 5 tickets for adults, because that's the information that they gave us. We also know that this right here is going to be our base ratio. This 3 to 5 is our base ratio. For every three child tickets we sell, we have to sell 5 adult tickets. If 2 students are selling tickets, then they're going to sell 3 child tickets and 10 adult tickets. If 3 children sell tickets, we're going to have 9 child tickets and 15 adult tickets. And you're starting to see a pattern, I'm sure. That we're taking 1 and we're multiplying it by 3. We're taking 2 and multiplying it by 3. We're taking 3 and multiplying it by 3. We're taking 4 and multiplying it by 3. Because this 3 and this 5 was our simplest form of the ratio. It was our simplest form. It's almost like getting a unit fraction. It's like the ratio that is the smallest in this sense. And using that, we can figure out what 50 is. Remember, if I multiply 1 times 3 and 1 times 5, and 2 times 3 and 2 times 5, then I multiply 50 times 3, and 50 times 5. And if you were to look at it in a different way, you would, well, no, that's the way we look at it. Sorry, I was going to rewrite it. There's kind of other ways to do it. So, how many tickets are sold if there are 50 students? So we know 150 child, 225 adults. We can now answer our question. The total is 150 plus 225. 375 total tickets. Now I'm going to ask you another question since I showed you how to do it, and you guys know you use that 3 to 5. You multiply the number of students by that ratio. Each one. So let's say there's 75 students. What goes here and here? And I'm going to give you some time to actually solve it. So, for the number of child tickets, you should have gotten 225. I'm giving you time to multiply 75 times 5. And you should have gotten 375 for adults. Okay, and that's a ratio table. It's just finding equivalent ratios. I'm going to show you one more example, and instead of going this way, you see how it goes up by 3 each time here and 5 each time here? We're going to look at it, instead of vertically, we're going to look at it horizontally. So our second example Example 2 says a recipe, here we go with our recipes again, for lemonade that serves 20 people calls for or asks for 2 cups of sugar, 4 pints of lemon juice, and 4 pints of water. Now, if I were asking you what the ratio is of sugar to lemon juice, then we would have to convert pints to cups. But I'm not going to ask you that. That's not what we're asking in this problem. But remember, if I was asking you to do a ratio of lemon juice to cups of sugar, we'd have to put those both into the same category. Okay. Instead, we're going to talk about how many people we're going to serve. So over here I'm going to write people served. And then I'm going to write sugar, lemon juice, and water. So remember, these labels were across the top in our last problem. Now they're going vertically. And so I'm going to say for 20 people served, like our problem tells us, I'm going to fill this in. 2 cups of sugar, 4 pints of lemon juice, 4 pints of water. Now I'm going to ask you, what would it be, how much of each ingredients, if we were only serving 10 people? If we're only serving 10 people. So here's where I look at, if I'm going from 20 to 10, what do I do? If I'm going from 20 to 10, multiplying or dividing, what am I doing? I'm dividing by 2. I hope you said, either out loud or in your head. So if I'm dividing 20 by 2 to get 10, I do the same thing to all of these. And that tells me what my new ratios are. 1 cup of sugar, 2 cups of lemon juice, or 2 pints of lemon juice, 2 pints of water. Okay, now I'm going to ask you about, my party is even smaller. Let's say this is COVID times, and you're making lemon juice or lemonade for only your immediate family and maybe your dog or cat or pet rock or fish or imaginary friend. And we're only going to have 5 people at this party. So, I could either go from 20 all the way to 5, which means I'm dividing by 4, or I could go from 10 to 5, which means I'm dividing by 2. Either way, you'll get the same answers. So if I divide 10 divided by 5, I'm dividing by, 10 divided, if I'm going from 10 to 5, again, I'm dividing by 2. And 1 divided by 2 is 1/2. 2 divided by 2 is 1. And same thing here. 2 divided by 2 is 1. So I'd have half a cup of sugar, 1 pint of lemon juice, and 1 pint of water. Okay, now let's say instead, let's say COVID's over and we're celebrating COVID being over. Woohoo! We're gonna get some kids and parents together, and we're gonna make some lemonade, and we're going to serve 50 people. So I could go from 10 to 50 and multiply these by 5. Or I could go from 5 to 50 and multiply these by 10. But since I like the number from 10 to 50 and I don't want to deal with a fraction here, I'm just going to go from 10 to 50 and multiply each of these by 5. So from 10 to 50, 10 times 5 is 50. So 1 times 5 is 5. 2 times 5 is 10. And 2 times 5 is 10 again. So the main idea is to break things or break the ratios to numbers you know using multiplication and division. Because if I didn't show you 10 to 5 and I just had the 20, if I only had the 20 recipe and I asked you to get from 20 to 50, it's much harder to get from 20 to 50. But if I get from 20 to 10 and I can get from 10 to 50, that's way easier. And they're all equal because they're all in the same ratio. We know 2 to 4 is a half. 1 to 2 is half. 5 to 10 is half. If they all break down to the same thing. And I shouldn't say half, I should say 2 to 4 is the same as 1 to 2 is the same as 5 to 10. And now I could even put something else on here, another number. Let's do 80. Let's say I'm making it for 80 people. Well, I'm not going to go from 50 to 80 because it's not easy to get from 50 to 80 using multiplication. But I can use 5. I can use 10. I could even use 20 and make it much easier on myself. So you can always break it down. So let's figure out what's 80. So you could use 10 times 8 or 20 times 4. Let's do 10 times 8 is 8 here. 2 times 8 is 16 here. And 2 times 8 is 16 here. All right, I want you, to do a to-do. You might have seen it. And we probably won't get to correct this to-do until next week, which is totally fine because if you're writing it in your math books, you have it. Just make sure you mark it in your sticky notes. Okay, I'm not going to give you a big scenario, blah, 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 girls, boys, they're in the school. All right, here we go. Girls. And this one we're going to look at horizontally. Boys. If there are 12 boys to every 8 girls. 12 boys to every 8 girls. What I want you to do now is fill out the missing pieces of this chart. And this is what we'll go over next week. And I'm just highlighting those so I know those are the numbers that we're filling out that we'll talk about next week. So you're going to move in this direction. Or you might have to go from here to here. It just depends. Depends on how you're going to break it down. All right, good luck.